Hi, my name is Lyla, and I'm a developer advocate at Google. And today I'm going to be talking to you about LiveData and ViewModel, as well as the Lifecycle library, which those are both part of. So prior to coming to Google, I worked at a ed tech company called Udacity, and I taught Android online. And one of the things that, as a teacher, I always noticed was that teaching the Android lifecycle is particularly tricky. The Android lifecycle is pretty unique to Android. So I think the core of the issue is that users expect their app to never lose UI state, whether it's online or offline, and they don't expect to be manually pressing a save button. Meanwhile, as a developer, you're dealing with the fact that your app might be taken out of the foreground at any point. The user could get a phone call, and then your app is backgrounded at that point. The user could flip their wrist and rotate the phone, causing a configuration change. Meanwhile, you could be trying to do asynchronous tasks like loading data in the background, and if you're referring to a destroyed UI, that's going to cause memory leaks. And also, the OS does this nice thing in memory-constrained situations where it will kill your apps. So to give a little background, the architecture components libraries were released in May. And the basic goal of these libraries is to help with common development challenges that we all face. And they can be used separately. So if there's one that you really like and you don't want to use the rest, they don't force you into using all of them. But they also work really well together. So the libraries that are out now, and I say out now because we're developing more of them, are Lifecycle, Room, and Paging. And Lifecycle Room are actually beta right now, and they're very soon going to be in stable. So that's exciting. And in fact, in support lib 26.1, Lifecycles are already integrated in that for activities and fragments. Okay, so as the talk name suggests, today I'm going to focus on the Lifecycle library. And along with the other documentation out there, there's also a document that was produced called the Guide to App Architecture on DAC. And I'm going to be following the architecture sort of things that were set out in that guide. And to help me with this, I'm going to be going through a couple of examples. So we're going to do a whirlwind tour of ViewModel and LiveData. And I say whirlwind because there's been a couple of other talks today about architecture components, and I want to get to some more interesting stuff. And then we're going to talk about communicating with a repository class. And we will finish it up with talking a little bit about dealing with persisting your UI no matter what happens. Okay, so these are the two example apps that I'm going to go over, and I'll talk about them a little bit more as we hit them in the talk. Okay, so let's start with a super simple example. This app is called Court Counter, and it's an app that was used in the Android for Beginners course, which is another Udacity course that I worked on. And it is very simple. It's a one-screen app. There's no database or networking. And there are two variables, the whole purpose of which is just to update basketball scores. Okay, there we go. So Court Counter is kind of one of these apps that has sort of a monolithic activity that's doing everything because it was for a beginner course. So this activity is responsible for holding the UI data. So it has the score variables stored within it. It's also doing all the sort of processing that the app does, which is calculating those new scores when the buttons are clicked. And it's also responsible, of course, for updating the data. So it has the text views in it and the activities updating those text views. And on top of that, of course, the activity knows about its life cycle and is in charge of handling that. Okay, so this, unfortunately, for newbies leads to a kind of subtle and sort of sad problem, which is that in the Android for Beginners course, we didn't really talk about the life cycle very much. So we have this issue where you lose state on rotation. Okay, so we are going to redesign this very quickly using a new sort of reactive UI approach and the new lifecycle components. So in our new vision of the world, we want all that the activity does really to be to update the UI. It'll also be forwarding all those interactions, but like its major purpose is just to update the UI. The ViewModel, on the other hand, which is a new class that I'll be talking about, the purpose of that class is to hold and process the data. The LiveData, which is also another class, makes the data which is stored in the ViewModel observable. Okay, and this is a little bit better than what we were doing before because the ViewModel actually survives configuration changes, which I'll be talking about shortly. So it's actually a much better place for the data to live and be processed. Okay, and the bonus is that you no longer suffer for that configuration change error. Okay, so ViewModels are objects that provide data for UI components, or that's sort of their purpose, and they survive configuration changes. Okay, you can kind of think of a ViewModel like this. The first thing you'll do is you'll take all of that UI data that used to be in your activity and you'll put it into your ViewModel. So the scores were in your activity instance before, you put them in the ViewModel instead. And then you associate your activity with your ViewModel. Then on configuration changes, like a rotation event, the old activity will be destroyed, but the new activity has a mechanism for getting the same ViewModel instance, thus giving it access to the same data. And the data was never needed to be bundled up in any way or serialized or anything, it's just there. Okay, so what's LiveData? Well, LiveData is a data holder class, meaning that it literally holds some data, and it also keeps it lifecycle aware, which I will go over in depth in a little bit. But one of the cool things is that it allows the data that's holding to be observed. Okay, so this means that we can have our UI observe data changes and then update itself automatically. And we'll talk about the lifecycle awareness in a little bit. Okay, so let's see what the code actually looks like. So here is an example of the ViewModel, and I'm just showing the score for Team A right now to keep the code sample kind of short. The first thing you're going to want to do is you're going to want to extend the ViewModel class. And now you have a ViewModel. The next thing that you're going to want to do after that is to put all of your UI data inside of the ViewModel. So again, this would usually be both of the scores, but right now I only have one of them. Mutable LiveData is a subclass of LiveData. We'll talk about how it's a little bit different than LiveData in a sec. And we just take our score that was previously there and we're wrapping it with the LiveData. Okay, and then we could do some initialization in the constructor there. Okay, then there's sort of two general types of interactions that you're going to end up having with the ViewModel. So one of the interactions you'll have is that there's going to be there'll be methods in there for when something in the activity changes, the ViewModel is going to know how to update and process the data to react to that change. So in this case, this is a method to update the score. Again, the ViewModel is responsible for processing data, so updating the score has moved into the ViewModel. And we also are going to have methods that expose our LiveData objects to the external world, which you're going to see why we need that shortly. So keep in mind that you're exposing the entire LiveData object and not just the values stored within the LiveData. Okay, so then you have your actual activity. So here's the starting code for that activity. So we want to be able to get that association to the ViewModel. And this statement here is the statement that sets up the association with the ViewModel. Okay, so the first thing that we're going to do is we're going to get something called a ViewModel provider. And that ViewModel provider is going to know about all the specific activity instances and fragment instances that have ViewModels. And then using that ViewModel provider class, we will use this get method, pass in our ViewModel class, and that is the thing that returns to us either the pre-existing ViewModel if it already existed, or it will go ahead and call our constructor for us and create a new ViewModel for us. All right. And then this is just showing how we leverage LiveData. So you're setting up an observer relationship here. So the first thing is we got to get the data to observe. And remember that data is now stored in the ViewModel, so we'll use that getter method that I showed before. And then we're calling the observe function on that. And into that observe function, we pass two things. First is the activity or life cycle it's associated with, and I will explain why that's important a bit. And second, we pass a observer, which just defines what happens whenever that data changes. Okay, so in this case, all observers have this sort of like one method in it called onChange, and that gets called whenever the data that's held within the live data that you're observing is modified. So here, our observer is getting a new score. whenever that score is updated, and then it is automatically displaying it for team A. Okay, so this is reactive because of this data observation. As you change your data, your UI is automatically going to get updated at the same time. So as we click those buttons to update the score, we don't have to manually call set text view as long as we set up that observer relationship in the beginning. And because we moved our data out to the view model, it survives configuration changes. So yay, that we got that for free. And there's now clear class responsibility. So the activity again is only displaying data, and the view model is doing all the holding of the data and the processing of that data that it's holding. Okay, so I'm going to go through some questions you might have now because I went through that code pretty quickly. So the first question might be, what's the lifecycle of a view model? Okay, so this is the diagram that we have up on DAC. So you can see over on the left, maybe it's whatever. You have some activity events going on. So the activity is created. We're showing an example of rotation, and then it's finished. And then you have the activity going through all of these different lifecycle events. And that dang view model is just sort of surviving throughout all of that. Even here, where the activity is recreated, and it's technically a new activity instance, the view model is still there. Okay, so the view model's lifecycle ends, and that's really the only thing that we care about, when the activity is either fully finished or if the fragment that it's associated with detaches. And sort of the interesting thing is that under the hood, view models use retained fragments that are associated with your activity or fragment instance that you pass into it. So a retained fragment is a fragment that has set retained instance to true. And this retained fragment is the thing that's sort of in the background surviving the configuration change. And this was kind of the previous way that we would tell you to be able to preserve data, through configuration changes if you wanted something that was really robust and could hold large amounts of data. But it was kind of tricky. There's a lot of edge cases. And with this new API, we've taken care of all that for you. Okay. So the one big thing that I should say, and I will be getting to this later, is if your process is killed, though, due to memory restrictions, your view model is destroyed. So you still have to handle that. But it is easy to handle. We'll see how to do that a bit. Okay, so how do you actually pass values into a view model? Okay, so you might have noticed that you're not actually the one who's calling your view model constructor. So you're not constructing your view model. And the default constructor for a view model is takes in no parameters. But there might be various points when you actually want to have some parameters passed into your view model. Okay, like let's say that we have a starting score. So your first option is nothing super special. It would just be to create a setter in your view model class, and then go ahead and call that setter right after you create your view model and pass in whatever data you need to set. But the second option, if you really want to be able to put things into the constructor of your view model, is to create a factory. Okay, so to be able to do that inside of your actual view model, here we have an example of a constructor that is taking something other than nothing. And then you would create an instance of this ViewModelProvider.new instance factory. The code's up online, and you can see kind of what those look like. But basically, that factory knows how to call your custom constructor. And then when you create your view model, you would pass an instance to that factory. And that's kind of what allows you to then call a custom constructor with a view model. All right, so, land a little. Okay, so one of the questions is like, well, why is this so hard? Like, why can't I just make my own constructors a little bit easier than this? And I think kind of one of the design decisions is that when you are passing things into a view model, we really want you to think about what you're passing in. Specifically, there's kind of this big no-no that you could do, which is accidentally pass a context into your view model. So view models have kind of transcended the Android lifecycle. They don't really care about the specific activity instances that are associated with them, which might be destroyed and recreated as their life goes on. But let's say that we accidentally, or not so accidentally, stored an activity instance in our view model. Well, then at that point, when we undergo a rotation event and create a new activity instance, Now we have to either manually update where that activity instance is pointing, or we're leaking at this point because we're referencing an activity that's been destroyed. Okay, so don't do that. Alternatively, you could go through, kind of keeping that activity instance in sync manually, but that sort of undoes one of the big benefits of the view model that you have, which is that you don't have to care about it. Okay, and as a little bit of a side note, having an application context within a view model is okay because its lifecycle the whole app, so you won't end up referencing a context that's dead. And in fact, if you want to do this, you could just subclass the Android view model, or sorry, you could just use the subclass of view model called Android view model, which already provides you an application context to use. Okay, so let's talk a little bit about what lifecycle aware means when we talk about LiveData. So in general, lifecycle awareness is this sort of new concept or the concept that's part of the library, which is that you'll have objects that are observing life cycles and will automatically adjust their behavior in accordance to the life cycle. Okay, so there's sort of three new classes and interfaces that are part of this. First is that we've made an actual object that represents the Android lifecycle, called Lifecycle. Second, we have an interface called Lifecycle Owner, which is any sort of object that owns a lifecycle. In this case, that means activities and fragments, usually. And finally, we have another thing that you can use called Lifecycle Observer, which is any class that observes a lifecycle owner, or well, any class that observes a lifecycle. Okay, so the first thing that you would do, let's say you have a listener that you want to be lifecycle aware. So you would implement Lifecycle Observer, and then in the constructor to that listener, you take in an instance of a lifecycle. And it would add itself as, it would take that lifecycle that it has and add itself as an observer to that lifecycle. And this gives us some sort of superpowers. Okay, so now our listener knows about the lifecycle and it can manage itself. So it can do things like query the lifecycle for its state and only take certain actions if the lifecycle is in a state where that would make sense to take those actions. So, for example, this statement is saying, like, if my lifecycle is in the background, I don't actually want to, continue going on with this method here. We also have annotations that you can use, which allow you to see or be automatically triggered when different lifecycle events occurred. So you can actually create listeners that are observing for these different lifecycle events and maybe know how to clean themselves up when the activity is in the background or completely finished. Okay, so LiveData uses all of this, and this is why we call it lifecycle aware. So using this connection, well, first, so again, I should point out that you passed in the activity when you made the LiveData, so that's how this connection is kind of initially started. So here, this is the onCreate in the activity, we're passing in the activity, and the observe method is setting up that association with the activity and the new observer object. So each observer has an associated lifecycle with it. So observers are associated with lifecycle, and observers will only forward events if the lifecycle that they're associated is in the started or resumed state. And what this means is if, okay, so one of the things that it could do is if your lifecycle is not in, if the activity is not actually in the foreground, you don't need to update the UI, so it won't be forwarding on those UI update events to it. When the activity is finished, it knows how to automatically kind of clean itself up. And if the observer reconnects or becomes active again, it intelligently gets the most recent live data, or most recent data stored within that live data. Okay, so this is a little bit of a softball question or a leading question that I threw to myself. So how about you make your activity do even less than it is doing right now? Okay, so again, the job of the view model is to process the data, and the activity is just there to display the data. Court counter emits a live data that has integers in it, but what we would really like, or what the activity really wants, is for it to be emitting strings. So LiveData actually comes with these transformation functions that help with that. And the simplest one is map. So map applies a function to every value that comes out of a sort of source or input live data, and then ferries that downstream to the emitting live data at the bottom. So using this, we can basically do that conversion automatically for us. And let's see what that looks like in the code. Okay, so here's our view model. And I guess I should sort of point out at the top we have score team A, which is the sort of the input integer live data, and then score string team A, which is the output string live data. So into our transformation.map function, we say, okay, we're going to be looking at score team A. And then we'll pass it a function, and what that's basically saying is every time score team A changes, I want you to run this function on whatever new value score team A got. And you can see it's converting it to a string right there. Okay, and then the output of that is going to go to the string version of the live data that we have there. Okay, and what I should say is, like, now that we have this score string team A, and you can actually see that I've made it public, we can just observe that live data that's emitting strings, and we don't even have to worry about the integer live data. So the integer live data is kind of taking the inputs of like the scores changing around, but the string live data is the one that's actually being observed by the activity. Okay, so you might have noticed that I've been using both this class called mutable live data and live data. So mutable live data, as the name implies, is live data that can be changed. And what that means is that it exposes the set value and post value methods. Set value and post value are just a little bit different. Set value is meant for being called on the main thread, and then post value can be called from a background thread. Okay, the actual live data class is sort of read only in that you can't change what's in it using set value and post value. Okay, so a general rule of thumb is that you'll only ever publicly expose live data outside of the view model, whereas inside of the view model you can use that mutable live data. So by using this encapsulation, you're kind of ensuring that the view model is always the one that's doing all the editing and processing of your live data, and everything outside of there is just observing the live data. Okay, anything else cool that you might want to know about live data? Sure. Okay, so live data is synchronous, which allows it to ensure some things. For example, a destroyed observer will never get updates. Also, live data is not a stream. Its purpose is to display the current state of the data. It doesn't have this concept of a history. So, for example, you would never want to use live data as like this object that's getting the most current chat in a chat application one at a time. You could either push down the whole new list of chats from the server, but you wouldn't want to use it in kind of like a stream-esque way. Okay, so as a recap, in our redesigned version of this, the activity is doing all of the updating of the UI, but it's not really doing anything else. The view model is holding the data for the UI, and it's also doing any kind of processing of that data. And if we want to make that processing cleaner, we can use the transformations.map function to help. We also ensure proper encapsulation within our view model by using live data versus mutable live data appropriately. And the live data, which is inside of our view model, makes this all lifecycle aware. So the activity will be automatically updated as the data inside the view model changes. Okay, so let's look at something that's a little bit more complicated using all of these classes that we just talked about. Okay, so we have a search app, and it lets us, search for the name of a song, and it returns to us any songs that, have names equal to or similar to whatever that name was. Okay, so there's essentially two pieces of data here. We have the search term, and then we also have this list of songs. And so naively, we can kind of start making our view model. We'll make two different live datas, one for the songs and one for the search term. And we could assume that we have Pojo that is a song and has all of our song data in it. And then we'll go ahead and we'll return those, provide a getter method for those songs so that the UI can observe as those songs change. Okay, so we know how to do all that, hopefully. And in our activity, we're probably also going to want to be observing M song since we provided it out. And then our activity will do all of the it will do everything it needs to do to be able to display those songs in a recycler view or however we want to do it. Okay, but this app is a little bit more complicated because we need to actually be communicating possibly with local persistence, and then probably we're going to be looking stuff up on the web. Okay, so to do that, we suggest making a repository class. So repository classes are gone over in detail in the Guide to App Architecture, but basically they represent the boundary between the UI layer and the data layer. And you should think of them as the single source of truth for all of the data in your app for your UI layer. And we do this because networking, like doing all our network operations and like deciding when we want to actually fetch data versus just getting something that's out of the local data storage is all fairly complicated, and we don't really want our UI worrying about that. We want our UI to be able to just say, get me the songs, and for it to get the songs and not be exposed to any of that kind of gnarliness that's underneath there. So because we're talking more about what's going on in the UI layer, I'm actually going to just black box this whole thing. And the only thing that you need to know is that in our ViewModel, we have an instance to this repository class, which you can see here. And then that repository class has one method that we're at least talking about right now, which is the search method. The search method will take in the song term that we're searching for, and it's going to return back to us a LiveData with a list of songs that match. And how it does that in the background, we are not going to worry about, but we'll assume that you implement whatever kind of logic that you want for that. Okay, so there's our method. And this is my chance to make a short plug for Room. So Room is another Room is another architecture component library specifically meant for making and managing databases. And it can return live data as well as RX flowables. So if you wanted to use it, it has those features for you. Okay, so how do we actually do a search? Well, a naive way of coding up a search method in the ViewModel might be something like this, where we just, okay, we're going to have a search method. It's literally just going to call the repository search method. And then we go, okay, well, we probably need to observe what comes back from that. So in our activity, when we do a search, we grab the search term from our edit text, and we pass it on to the ViewModel to do that search. And with the resulting live data that the ViewModel delivers, the ViewModel via the repository delivers back to us is something that we are going to then observe and display in our UI. Okay, so the issue with that is, well, let's go through an example of what would happen if we did that. So I feel like looking up a song from Hamilton called My Shot. And so this is where I'm calling it for the main activity. It kind of gets ferried onto the repository where this method is called. And then I do all of that sort of processing in the background to look up a live data. And a live data from the search, My Shot, is returned to me. Okay, and then because of how we coded this, the activity gets that back and is actually observing that list of songs that was returned to us. Okay, so let's say that I'm in a Taylor Swift mood and I want to look for a song of hers. So maybe I'd search Shake. And that's going to go through the same process where the activity tells the ViewModel to do a search, the ViewModel tells the repository to do a search, the repository does a search for me. And at that point, it returns the new list of songs that we have, the activity observes it, and now the activity is observing two different live datas at this point. So every single time that we're calling this method, we're actually going to be looking up a new live data and creating a new observer connection. There's nothing in there where the live data knows to delete or remove any of the old observer connections that it had before. So instead, we're going to use another transformation method called switchMap. SwitchMap looks sort of similar to map, but what it does is it basically switches out the observed data based off of another live data that's emitting a value. Let's see what that looks like. Okay, so in practice, what it's going to do, and then I'll show you the code. You will set up a connection between your activity and your songs, where your activity is observing your songs. Okay, then when switchMap is called, it's going to associate the search term LiveData. Okay, actually what I should say is it's using the search term LiveData, and whenever the search term LiveData updates, it's going to call the repository with that new search term. The repository will find the new LiveData for us. And then it's going to do this kind of magical swap thing where msongs is now going to be referring to the new LiveData that we just looked up without having to change around any of the observer relationships that we had before. And then that updates our activity. So then when we search for something else, it kind of goes through the same flow. We change what the value of the search term is. This auto triggers an update for the repository, which finds us a new LiveData, which is swapped out and emitted to the msongs. And because of the observer relationship, the activity UI is updated. Okay, so what does this code look like? It's actually pretty simple. So here are our two LiveDatas. We have the search term, which is kind of the input LiveData, and then we have the songs, which is sort of the output LiveData. Okay, there's our transformation statement. So we supply the input LiveData, which is the search term LiveData there. And this says whenever the search term changes, you're going to call this method with the new search term, the repository.search method. Repository.search, if we remember, returns to us a LiveData. And we are going to then, via the sort of magic of switch map, have msongs observe that new LiveData without having to update any of our observer relationships. Okay, so then when we actually want a method for the ViewModel to do searching, all we need to do is have a method that updates the search term LiveData. Okay, so externally from the activity, we'll call this method that updates the search term LiveData, and then we kind of come back to here where this whole process starts, where it takes in the new search term, emits it out, the repository does the search, and then msongs gets updated. Okay, and then don't forget that you all actually need your activity, the code for where your activity observes what's in msongs. Okay, so map is used for sort of simple conversions from one type of LiveData to another type of LiveData. The difference with switch map is that it's actually changing the underlying LiveData, and it's useful for things like using a key or an ID or a search term to look up LiveData. Okay. One of the things to know about this is that both of these transformations, and actually basically everything that's happening with LiveData, is being run on the main thread. It is synchronous. So you shouldn't be using the map function to perform like long database lookups, because that's all going to be done on the main thread. And then when you're using switch map, what's actually happening is switch map will whatever function that switch map is calling is going to create an empty LiveData for you at first, and then it's probably also then firing off in a background process the actual code that it wants to do to do a database lookup or a network, pulling something down from the network, and then it's going to update that that LiveData that it passed to you. So let's see kind of what that looks like. Okay, so let's say that we're doing this search where we're looking for the song My Shot, and it's gone all the way down to the repository. So the repository does whatever the repository is doing in the background. So the first thing it's probably going to do is it's going to spawn a background thread, and that thread is going to be doing some sort of lookup. Then synchronously, after it's spawned this background thread, it's going to return an empty LiveData that it is going to continue knowing about. So msongs will be updated with that empty LiveData. Okay. Then after a little bit of time passes, you will post whatever value that you got from that background processing that you were doing. So I've mentioned before that LiveData has both a set value and a post value. Post value is meant to be used when you're on a background thread, such as this scenario. Okay, and then that'll update the activity UI. Okay, so under the hood, this is all using a class called mediator LiveData. And I probably did not have enough time to go over sort of what mediator LiveData is doing, but it's worth looking into. There's some cool code in the guide about handling state, and you can also make your own transformations using mediator LiveData. I got the 5-minute warning, so I'm going to go over quickly. This is just a sort of a recap. So use a repository because it's cool. It's a boundary between your UI and data, provides a clean API, and it can be the source of truth for data in your app. Use switch map if you ever need to kind of do that swap with the underlying data. And then remember that switch map and map are the main thread. Okay, so let's talk a little bit about persisting UI state. So remember before how I said that view models don't survive process death. So process death happens in constrained situations where the OS will go, crap, I'm doing too much, I need to kill off some apps that are sort of less important. This is a violent thing. No lifecycle methods are called at that point. Though your foreground processes are given priority to keep running, so this usually happens with processes that are in the background. And in general, you will use unsaved instance state to recover from this. Okay, so again, view models, though, don't survive this. It gets killed along with everything else. Okay, as a sort of side note, if you're testing this, don't use the don't keep activities setting to test this, because that only ensures that your activities will be killed, but not the entire process. Process death kills the entire process. It's not killing like one activity at a time. Okay, so at one point, when we're talking about sort of restoring UI state, let's take a step back and talk about when do our activities die. Well, they die when we explicitly tell them to finish. They die when a user swipes them off the recent screen, when the user navigates back. They die momentarily when there's a configuration change, although they immediately come back to life. And they also die in this process death situation. Okay, but the user's expectation is different in these different states. So if like you do something in the app with that and you actually call finish, you probably mean for the activity to die, and the user probably is going to expect to come back to a new state. Similarly, if the user swipes it off the recent screen or navigates back, they don't expect to ever come back to that instance of the activity. Conversely, though, if there's a configuration change or if they put their activity in the background and it gets killed, they do expect to come back to the usually to come back to the exact same state of the activity. So you have to kind of manage those two situations. Luckily, as we talked about ViewModel before, that deals with a configuration change situation. So what do we do in the process death situation? Okay, there are kind of 3 different places that you can keep UI data. One is, so we have persistence, the ViewModel, and on-save instance state. Persistence, we could be thinking about our local, maybe SQLite databases. Generally, the data that we're keeping in there is UI independent, and we should be pretty much saving everything at the point at which we get it. I'm gonna skip over some of these slides. Okay, so this is basically saying like, as soon as you do any kind of processing and look some data up off the internet, you should be saving that in a database if you want your app to work offline or just in general be able to return back to expected state. Okay. The view model we've kind of already gone over. You should be putting everything that the UI needs to be able to display its state in there. This includes things that you might not necessarily save in the database, like transient UI state. For example, the current filter options that you might have for a song, or maybe the song's playback position. A view model is also great for large items like cover art or media files or all of the data for your recycler view that you've loaded up. What's not great for that is the bundle for unsaved instance state. So this is sort of a plan B thing, and the purpose of the bundle that you store in here is it's meant to save the smallest amount of data possible to be able to then restore your state. And you can kind of see this coming into play because if you try to cram something like a large media file in there, you're likely to try to put something in that's like too big for the bundle, and you'll get a transaction too large exception. So what would this look like in song search? Here is our view model. Okay, so the smallest amount of data that we would need to restore UI state is the search term. So we would expose that search term. We'd go ahead and we'd save it up in the unsaved instance state bundle. Then in onCreate, we'd get that search term back. Okay, and we'd probably want a ViewModel factor in this case. So we could pass, when we are reconnecting to the ViewModel, we could pass in the new, the search term if we got a search term. Well, we pass in the search term regardless. And so one of the things just to note is that the activity is just passing along whatever's in the search term, and the ViewModel is the one who decides what to do with it. All right. And then here in our constructor, we have a search term, or if we have a search term, we reperform the search to get the UI state back to where it was before. Okay, so this is just a little recap of that. And if you want to learn more, here are a bunch of links. So check out our samples. And I also have a couple of blog posts on this stuff if it's interesting to you.